We know that ideal gases follow the ideal gas law, PV is equal to nRT. But in reality, gases are not ideal, and they behave very differently at different pressures and temperatures. In order to understand this behavior, scientists measure the properties of various gases under different conditions and calculated how much a gas will deviate from ideal properties in any given circumstance. As a result, they created a general chart called the compressibility chart, which uses the compressibility factor, Z. The compressibility factor is defined as PV by nRT. On rearranging this, we get the form PV is equal to Z nRT, which is called the real gas law. This law gives the actual relationship between the properties of a gas. So the compressibility chart helps us understand the actual behavior of gases under specific conditions. For example, if Z is equal to 1, then the equation for the gas is PV is equal to nRT, which is just the ideal gas law. So the gas behaves like an ideal gas. Similarly, if Z is 0.4, then the relationship between the properties becomes PV is equal to 0.4 nRT. In order to find out the value of Z using the compressibility chart, first, we need to understand what reduced properties are. Reduced property is basically the given value of the property divided by its value at the critical point, also known as critical value. So reduced pressure PR is the given pressure of gas divided by its critical pressure, or P by PCR. Similarly, reduced temperature TR is the given temperature of gas divided by its critical temperature, or T by TCR. The compressibility chart has reduced pressure on the x-axis and compressibility factor on the y-axis. Inside the graph, there are many lines which denote different reduced temperature values. So, if we know the reduced pressure and reduced temperature for a given gas, we can find out the compressibility factor using this chart. For example, consider water or steam at 700 Kelvin and 600 bar pressure. For water, the critical pressure is 221.2 bar, and critical temperature is 647.3 K. So we can calculate the reduced pressure from given pressure by critical pressure as 2.71, and the reduced temperature from given temperature by critical temperature as 1.08. Remember, reduced properties do not have units, because they are just ratios. They show us how close we are to the critical point. Using these values in the compressibility chart, we find the value of Z is approximately 0.38. So the equation for the steam at given conditions is PV is equal to 0.38 nRT.